This has been a Costora group. This is week 7-8.
I'm Josh Costora.
I'm Reginald Bennett. Yeah, go ahead.
And this is our week of the bag of tricks. Actually, this is 2 weeks combined because we didn't accomplish as much as we wanted to last week. So
we want to show a little bit more. So, as 28th of July, summer 2014, we have the University of Maine at Orono with the SIE 598 Augmented Reality class. So as we said, we combined 2 weeks this time just because we were working on a bunch of stuff and it would have been just talking last week, so we wanted to wait until we actually had something to show.
Yeah.
So we combined the last 2 weeks into one. We ran some tests, just little different tests, but one of them that we helped us with a couple of our demos was we set up some different size marker sheets trying to determine at sitting level, so essentially 1.5 to 2 feet away from your eyes to the table, which marker size would work the best. I had it printed on laser printer and it was very clear, and we found it was about 1 inch was the best. We could get down lower, but it started to get a lot more jitter and a little less reliable, so we decided to try and whenever we made our printed demos, make the markers 1 inch.
Yeah, we did try 3/4 of an inch, but like you said, they got jittery, and I think if the cameras on the glasses were a little more high def, we could get smaller, probably close to a 1/2 inch, and still be able to use them reasonably without it looking horrible.
Yeah, it would. So on this, this is 1 inch right here. It would actually recognize this one. Every once in a while, we had like a little fish demo running, and every once in a while, the fish demo would go there, and we found that if we had a moving demo, it wasn't so bad because we couldn't notice the jitter, as we've mentioned before. But when you move the page around, it didn't faithfully track that small an image. So a few new demos this week, some things that we've kind of worked on and just put a little more polish on them. 2 MaxReality demos.
And then we got a coding demo finally to work using the markers that come with the MaxReality stuff.
Yeah, so I mean, more impressive than necessarily the demo is the fact that we now have that environment working, so now we have the ability to start doing a lot more custom stuff.
Yeah, we have something to build off of now. So.
Yeah. And we also, one of the things we're going to turn in and probably report here on a video is a comparison between some of the current augmented reality glasses solutions I have out there, as well as some stuff that's being proposed and is actually likely to come out. We'll probably limit it to wearable stuff like glasses, so we won't go into the whole showing with tablets and things like that.
On that note, I did read something on Facebook because I followed Vuzix that they're working with Lenovo to release their glasses in Japan.
Okay.
They just had a big announcement that I just read about. I think it was yesterday on my Facebook feed.
All right, so in the next couple of weeks, we'll probably put up a few different slides to show you, hey, what's out there, how does the 920 wrap ARs compare, and then also you can see in that really cool picture, we improved the nose piece substantially. The nose piece that comes with it tries to be like glasses. That's 2 little rubber pieces that go on the sides of your nose, but it's bound to the glasses in this really weird way, which we found after a few uses just came off and
Yeah.
doesn't go back in, and we don't want to take the glasses apart to try and reseat this thing. So we've been just kind of resting the hard plastic on our nose, and we got sick of it today, and just that's innovation right there. So we could probably stop the brief now with that piece of paper that's folded about 8 times and just shoved between the glasses of my nose, and that's probably good for this week. I mean, that's progress.
It is.
As far as MaxReality, we've been talking a bit about the limitations, capabilities, and also the potential of Vuzix proprietary software, MaxReality, that works with inside 3DS. And so once we saw some limitations, trying to look at markers across the room, put plants and all the jitter and stuff, it was suggested, and we went ahead and went forward with, let's try and create a couple things that work within the functional scope of the glasses. And with that, we reduced some of the projects we were going to work on, and I went ahead and made these 2. Here.
So the first one is a demo map, and we're actually using the university map, and the idea is that we have, like, you can see a 3D image of the buildings, of each of the buildings on the map, so when you look at it wearing the glasses, you can actually get a more realistic perspective instead of just like a flat 2D plane with just like a square drawn on it. You can actually see a 3D representation of the building. It could potentially help with navigation for new students coming in, or parents coming to visit their students, or visiting faculty, or stuff like that.
Yeah, so when you have different dimensions, then it might be easier for some folks to get a better spatial awareness of what they're looking at rather than just a flat image. So so that's the map. That's going to be a simple use of the software. And then when we show the map, we'll talk about the low res thing here. And then we also created a menu, which was one of the demos we were talking about. And essentially, that takes multiple markers and allows you to preview an item. Again, it uses some functionality we discussed in previous reports. And we'll go ahead and walk through all those. So here's the map. You can see this is the actual university map minus a university logo here. We put a marker there because it was the least intrusive place. The only problem with this particular map is that the colors are all very like pastel and light, and so when you're wearing low resolution glasses, it's really hard to make out the roads or buildings. So what we did was at least we changed at least where the roads are, and then also where the different parking areas are. That's what the big blue things, those are parking lots for residents, commuters, things like that. So it makes the map a little bit easier to actually see in the glasses. And then we want to pick out probably different colors for the buildings, but we don't have access to the actual base or raw file for that map, so we might regenerate that in some way later on. You can see down there the size comparison we did. Put the iPhone there so you can kind of get a relative idea of how big each thing is. In the bottom left corner, what you're looking at is a 3DS pre-render of what you'll see on this video in a minute, and that's the two gray bars are essentially on the top are going to be labels. They show where Boardman building is and Carnegie building. Those are the two primary buildings that we do virtual reality and augmented reality research out of. And then that base square there is going to have the UMaine logo, and that's going to replace the marker. Since the marker isn't really there for the user, it's just for the tracking software, we replace that. So we'll show you the video. And this is on a webcam, not the glasses, but it kind of gives you, this is a little bit higher resolution than the glasses actually. But point to where Boardman and Carnegie are right now, and when I move the placeholder, alright, so now you can see it says Boardman, Carnegie, and you can actually see 3D cubes representing where those buildings are. And as we rotate the map around, you'll notice that the marker allows the software to keep track of where everything should be positioned, not only on XY plane, but on Z plane as well, along with the rotations. So simple usage, it's a static use of augmented reality to augment something that's giving you information with either more clear information or additional information. So that's the first demo, and then we'll continue to improve on that. Second demo.
So this is the menu demo that Reggie talked about earlier. As you see in the upper right, we have those are the M0, M1, M2, and M3 are the markers that would designate 4 different food types. In this case, they designate different shapes: a square, a cylinder, a torus, and a sphere. And then when you actually select one with an additional marker, it appears where S0 is, which would be the plate. So you would select your food item, and then you would get a larger image of what it would look like. In the bottom right, you can see that's the 3ds Max pre-render, which you can see all the shapes start at the origin, and then when the marker is detected, they expand out. And then you can see to the left of the jumble of shapes is a little gray triangle, and that's actually the marker that you choose with, and we had to separate that so when it gets initialized, you don't automatically select an item.
And then you can see when we talked about portals before, when I took a screenshot of the file folder, and you can see there the Max files and the VWDs. VWDs are what run through the MaxReality software, but we use these 5 files to portal in between. Now, right now, the top left, as was described earlier, which is the 4 mobile markers all vertically in a column, and then to the left is the plate with the static marker, which is essentially like kind of an origin or 0, 0 point for the whole demo. This is together right now, but the kind of the final concept idea would be, okay, would it be cool to go to a restaurant and get a menu, and it talks about, okay, here's some hot dogs, here's mashed potatoes, here's a turkey dinner, whatever, and it gives maybe just one sentence or a brief discussion about it, and then you through your glasses that, because obviously in the future we'll have a lot of augmented reality glasses with everything, use the selector and you say, okay, well, hey, I'd like to see a hot dog, I want to know more about it than what's just right here, which is just the title in one sentence. So you would select the hot dog, and then appearing on your plate in front of you, which is what's simulated here, would be a picture of the actual, product that you would get, like the hot dog with the fries and everything, and you'd be able to look around, look at it, and like, oh, okay, that looks good, or no, I don't like that hot dog, that looks crazy. So, and then you can select through the different things in the menu, and not only will the menu pop up previews on your plate, but it would also give you, a lot more like nutrition information or reviews. Like for instance, you could always combine this with something like Yelp or whatever. So you go on there and be like, oh, when I go here, not only does the hot dog look good, but 9 out of 12 Yelpers think that this is an amazing hot dog. So I'll go ahead and order that. So that's kind of the idea. Obviously, we won't go that far with it, but on here, and so before I go to the video, something else I want to discuss is that in its current creation with the menu markers and the plate marker being on the same page, that's actually redundant. You could actually use the static marker and then just offset all the shapes, which we'll talk about in a second, off of that 0, point, and you'd be fine, because you could have those shapes exist and have the selecting marker touch those offset shapes. However, the reason they're like this is because we really want the menu to be separate from the plate. So you might look to your right, select what you want, the program remembers it, and then you look to the left of the plate, and that's what's there. And so that's something that we could hopefully be able to do a little bit easier with the coded environment, because we can actually make case statements and select, and
we can remember things.
Right, rather than, as we've talked about before, all the markers have to be visible at the same time, otherwise you get crazy bugs. So I'll show you kind of this working. So you have the marker to the side, and you have the initial block of cheese, and I select the red, and then right here it's going to select over to, so again you're getting a small preview of what's there, and then you get a large preview once you actually select the item. But you can see even at this size, some of this stuff is going crazy.
Yeah. You can also see that the collision of the two objects does not designate a transition, so that's why it's the actual how it collides is hard to tell. So we had to make the pointer bigger in order to make it work more smoothly. Before, the first time we tried it, we wouldn't actually change objects because they would never select each other, I guess.
Now what was interesting about that was a lot of times it responds easier or faster if your selecting marker becomes obfuscated anyway. If it disappears and the system has to be like, oh, something disappeared, it's almost as if it forces an update, and then you'll find a lot more reliably the preview, the thing on the plate changes. We've had other instances where, and we can always change the marker to be like a big cube or something a little less aesthetic, and then it will react easier. But yeah, we were finding that if you just cover a little bit of the marker, which should make the marker disappear, it forces the system to reassess where that marker was pointing, and then it goes from there.
So this is the setup that I was using for the OpenCV tracking. You can see on the screen that I have the image on the right is actually just a static marker that I'm trying to detect, and then the live feed is on the left, and I'm holding the marker. And in the demo, you'll see that the marker actually gets surrounded by a very thin red box, and then you can track it around. So the idea behind this is we could eventually load whatever markers we want, and then the program can detect when it sees those, and this is how we could use our menu, and we could remember, okay, we've seen marker M0 and M2, and then we know what to do, what to render on those. This is mostly using built-in OpenCV functionality. It's a little coarse. I gotta see if we can fine-tune it and make it a little more responsive. But it's also built on the line detection code that we showed last week. That example, basically I stripped all that code out to just the core base, and then built up with importing a new live feed, importing the image, and then trying to find the static image within the live feed. So it right now it's detecting nothing, but it still draws the red box. And you can see it picked up the marker, and will track the marker as I move it around. But as I get close to the top of the screen in a second, you can see it kind of jumps down, and I'm not quite sure why it does that. I have a feeling it's similar to the way MaxReality has issues with tracking the markers and some sort of jitter. But now that I got it working, we can try and make it work better.
And so, of course, the first step is just tracking, where it is on a two-dimensional plane, which is left to right across the screen, and then using, once we get that kind of narrowed down, which is then to try and throw in the geometry to figure out, okay, if the image is tilted, then let's interpret how we think it's tilted, and then change a particular object.
Yeah.
I mean, getting the software to work is obviously key to a lot of stuff, but yeah, so it opens a huge door for us to okay, so now we gotta we'll see what type of representations we can put in there to cover a track, whether it be a 2D representation or 3D, and then if we can get the turning and the rotation to work as we want, and then once we have those things going, then we, as we discussed earlier with the menu, we can start doing things where we start doing case statements and actual logic based on markers in the real world rather than just one-to-one relations. We can do combinations type things and unlock the power of a computer.
Yeah.
So yeah.
Something else I want to point out about that demo is you notice the red box is very large, and I discovered just before we started recording this that red box is based on the size of the static image. So if you give it a smaller image, it'll try and detect a smaller. If you give it a smaller static image, it'll try to detect a smaller image in the live feed. So that may play into account later when we're trying to work these demos as to how small of a static image we can give it and still be able to detect the larger images in the live feed.
So, like we said, we'll talk about, here are the things we'll go in the future. One is continue that research about current next-gen augmented reality glasses. Work on improving the MaxReality demos a bit more, just so if we bring in folks who aren't familiar with the tech, then maybe it's a little bit more impressive initially. So we'll just polish that up a little bit more, and then
And we focus more on the code now that we have a solid base to build off of, and see how far we can push it and how easy it is to get it to do things like rotation and track the orientation of the marker, so that we can do something similar to MaxReality but have more ability behind it, because we can track changes and track how the markers align together and remember things and more logic.
So yeah, that'll be definitely the focus is the coding environment. So that's this week.
Yeah.
Thanks for watching.